students. Today I just prepare you for interview. Actually, I already wrote a book in 2011. That book is How to Crack Interview in Java. You can subscribe it from our websites, and also you can use it from the link also. Now from there I can show you some application that give you some courage to face the interview. Facing an interview is just a very simple thing, but you have to understand how to write the code and what type of question they will ask you. They just misguide you. I show you one application. Every day I show you 10 application, how I elaborate how they will work, that give you some courage to face the interview. Now you check. This is the first application. I just write here. You know that in this case what happens? This is test 1 is the name of the class. I entered into the main. Inside the main method, I declare a class. The class name is foo. Foo is the class. So remember, this concept in Java is called as local inner class. I think our student already knows that there are 4 types of inner classes are there. Static inner class, non-static inner class, local inner class. Another one is anonymous inner class. So it is the concept of local inner class. So here you see, inside the method I declare a class, means that is the local inner class. Inside the main method I declare the class. Now fine, you know that inside the local inner class I declare a variable called as I. What is the value of I is? Here I value is word 3. Fine. That variable is declared within a local inner class. See. Now what is the next line? Next line I just make some confusion here. In the interview they create some confusion. Here you see. Just like they write here object O. You know that O is the reference of which class? Object class. But I am creating the object of which class? Foo. You know that in case of Java, every class inherit from which class? That is object class. Object is the base class for every class. There is no need to use casting. But if I use casting, it's not an error. But it is useless. This line is useless. It is not required. This concept is not required. But if I use it, it's not an error. Now you see, I can write like this. Object, here you can write O is equal to, that is a new, I can write here foo. That is also successfully executed. No need for casting here. But if I use casting, it did not generate any error here. No error. Now, if it is not error, it is syntactically right. Then it moves to the next line. I just write foo. Foo is the name of the class, local inner class. That is the reference of the local inner class. What I pass here, O is the reference of which class? Object class. You know that object is the base class for every class. The base class reference never be assigned to the child class reference. What do you require here? Here typecasting must be required. Must be. Now I am using casting. Syntactically right. No issues are there. You know that inner class member is always extracted by the reference of which class? That is our object of the inner class. Inner class member never be recognized by the outer class object. So what I can do here, I have to create the inner class object. Through the inner class object, I extract the member. What the value is? Value is 3. It is syntactically right. The result is word 3. I think this is the result. Here you see, it is the concept of local inner class. I just give you some ideas. Casting is mandatory here. Typecasting is mandatory here. Typecasting is not required here, but if I use typecasting, it's not an error. Syntactically it is right. And what is the result? Result is word 3. So C is the result. I value is 3. Are you getting? That is the first explanation. I just explain. Now, I move to the second program. Check here what I can do here. Now, this is all about the first program. Now, I move to the, that is second application. See, this is second one. Its execution is very simple. I entered into the main. Inside the main, what is the value of I? That is the I value is what? That is 1. What is the value of j is? That is 10. Now you see, it has, I write here do. Inside that, I pass a condition. What is the condition I write here? If I plus plus. You know that 1 plus plus. 1 plus plus is what? 1. It is post increment. 1 greater than, here it write, that is minus minus 10. It is what? A pre. It is a post, it is a pre. It is a post increment, it is a pre increment. Now pre decrement, so minus minus 10 means 9. Is 1 greater than 9? No, the condition not satisfied. When the condition not satisfied, the statement is not executed. It is not executed. Fine. If the condition not executed, it enter into which block? That is while block. Here you see. Now what is the value of I? I value here is what? 1. But when it move to here, that is the I value is 5. That is 2. Now 2 less than 5. Is your condition satisfied or not satisfied? Satisfied. When the condition satisfied, it move to another time. That is the do block. Inside the do block, I write here, I value is what? 2. Now it is 2. 2 plus plus is 2. 2 greater than. Minus minus, that is 9. Minus minus 9 means what? 8. Is 2 greater than 8? Not satisfied. Fine. Condition not satisfied. When it move here, that is fine. While I just pass here, that is 3 less than 5. Is your condition satisfied or not satisfied? Satisfied. Another time it enter. Now it is what? That is 3 plus plus. 3 plus plus is what? 3. 3 greater than. Minus minus 8. Minus minus 8 is what? 7. Is 3 greater than 7? No. Condition not satisfied. Here you see. If the condition not satisfied, it move here. While. That is the 4 less than 5. Is the condition satisfied? Yes. Now when the condition satisfied, enter here. That is the 4 plus plus. That is 4. 4 that is greater than. That is a minus minus 7. It is what? 6. Is the condition satisfied? Not satisfied. The condition not satisfied. Now 4 greater than 6. Condition is what? Not satisfied. Now it enter here. While. What's I pass here? 5 less than 5. Is your condition satisfied or not satisfied? Not satisfied. Now when the condition not satisfied, it quit from the loop. When it quit from the loop, what is the value of, I print the value of I. What is the value of I is? 5. Now it print the value of j. What the value of j is? It is 6. Is 5 and 6 is the result. Is there any, that is what, is there any, that is option is there? Yes. The last one. This one is, that is here you see, that is D is the result. That is I value is 5, J value is what? 6. So in this way, you just try to solve the problem. How it will work, I show you. Now, first and second program I show you. And I already show you that how it will work. And as a developer, how you can calculate it. Now, I move to the, that is third program. Check here. What actually happens in case of third one? You know that here the execution starts from which block? That is main. Now, what I can do here, that is test3A. You know that when I pass here test3A, here A is a local reference. Fine. When it is a local reference, it will occupy the memory from stack area. I just write here new test 3. I construct the object. You know that when the object is constructed, it will occupy the memory from the heap area. I already elaborated these terms to our students. Everyone must know the memory management in case of Java. This is called as JVM occupied memory space. Now, the size of the object depends on which variable? Instance. Now, how many instance variables are available here? Here you see. Here, that is I is an instance variable and TT is a instance variable. You know that I is, here you check, I just show you what actually happens. Check here, when the object is constructed, here you see, the size of the object depends on which variable? Instance. Now, how many instance variables are available here? 2. One is what? That is I. You know that if I am not initialize it, they are auto initialized by the default value. What is the default value of int is? 0. What is the default value of reference is? Reference default value is what? Null. Now it will occupy the memory from which area? Heap area. You know that the size of the object, if take an example, it is 1000, it is assigned to A, point to this object. Now anyway, the object is constructed. After that, I call A dot start. Here you see, I call this method. When I call this method, what it write here? T is equal to new test 3. That is TT is equal to new test 3. TT point to a new object. When it point to the new object, another object is constructed. Here you see. A reference must hold the base address of another object. Now, the size of the object depends on which variable? Instance. How many instance variables are available here? That is 2. I is initialized by 0. TT is initialized by null. If the base address of the object is 2000, here you see. What it contain? Now you see. Now it contain 2000. So it point to this object. Are you getting? Now what is my next job? Now through this object I call, that is start method. Next, would it write this? This means what? Current object. That is this dot, that is take demo TT. Here you see. This means the current object. Who is the current object inside the start method? Here you see. The current object, I just point it to the current object dot take demo. Take demo is a method. Here you see it call. Through the current object it call this method. Now I pass the TT. TT means what? Same object I pass here. It enter. Now when it enter inside the block, that is T is a reference. Here you see, it will occupy the memory from stack. Now would it happen here? That is for the first time it is what? Null. Now would it write T is equal to new test 3? That is what? Another object it creates. Here you see, that is third object is created. Here you see. Now when another object is created, it will occupy the memory from the heap area, and that is the third object is created. Now here I value is equal to 0. I value is 0 and TT is equal to, that is null. Now what is my next job? I is equal to 10. I call it by word this object. Here you see. When I call it by this object, what I can do here, for this object, I value is, that is 10. After the job is over, here you see, after this job is over, I value is changed to 10. Now execution is over. It back to which area? This line. I plus plus, 10 plus plus is what? 11. Now after I value, here I value is what? 11. After it is 11, it will back to the main, this line, system out println. What is the value of I? A point to this object. For this object, what is the value of I is? Listen, it is 11. The first option is right. Here you see, I value is 11. That is right. This means current object through which I call the method. I call the method by the help of word. Which object? That is the start method is called by which object? This object. Now, what's the result is? The result is word 11. Check here. Now, that is the third explanation. I just show you. This is the concept of memory management. Try to understand. Memory management is one of the crucial part or one of the crucial section in case of word Java. Now, after the third program, here the result is word 11. It is the first option is the right one. Now, after that, I move to that is the next part. Here you see. The second program, like similar to the second program, it is the use. What I can do here, I value is 1, that is j value is 10. Here I pass the condition, that is if that is 1 greater than 10, is your condition satisfied? No. So this line never be executed. What did write here? J minus minus, 10 minus minus. After the line terminate, it is word 9. While plus I, plus 1 means word 2, 2 less than 5. Is your condition satisfied or not satisfied? Satisfied. When the condition satisfied, move to do part another time. That is 2, that is greater than 9. Is your condition satisfied or not satisfied? Not satisfied. Then that is what 9 minus minus. When it is 9 minus minus, it is what 8. While that is plus 2. Plus 2 is what 3. 3 less than 5. Is your condition satisfied or not satisfied? Satisfied. Another time, enter into do part. I value is what? I value is 3. 3 that is greater than 8. Is your condition satisfied or not satisfied? It is not satisfied. Now it is what 8 minus minus. Yeah, you see. 8 minus minus is what 7. That is plus 3 is what 4 less than 5. Condition satisfied or not satisfied? Satisfied. Now another time enter into do part. What is the value of I? I value is that is what 4. What is the value of j is? 4 greater than 7. Is your condition satisfied or not satisfied? Not satisfied. Move to here. That is a 7 minus minus. That is what 6. While plus 4. Plus 4 is what 5. 5 less than 5. Is your condition satisfied or not satisfied? Not satisfied. When the line terminate, what is the value of I is? 5. What is the value of j is? J value is 6. Check here. Where the value is 5. Here the I value is 5. Sorry. That is the B is the right answer. I value is 5. J value is 6. That is the right answer. Sorry. That is the B is the right one. Check here. That is the B is the right one. 5 and 6 is the result. Now, after that, I just do one thing. Move to that is word, that is the next part. See here. That is the fifth program. Here you check. Now, you see the program first. It is the concept of word. Call by reference. You know the concept. Now, here what happens? Some part is only modified. Check here. What actually happens, I show you. That is how it will execute. You know that execution starts from main. Holder H. You know that H is a local reference. Occupy the memory from stack. Check here. I construct a new object. You know that. Occupy the memory from the heap area. You know that the size, this is the holder object I create. There is no constructor is available. I am calling the non-parameterized constructor. So it called the default constructor. Object constructed means the size of the object depends on which variable? Instance. How many instance variable are available here? Only one. What is that? Held. Here you see. I have not initialized it. At the object creation time, it is initialized by 0. If the base address of the object is 1000, it hold 1000, point to this object. Next line, h dot held 100, h point to this object. For this object, value is word 100. Then third line, h dot bump, what I pass here? H. I call the bump method through this object, but what is the parameter I pass here? Parameter is the same reference I pass. Yeah, you see. Bump is the method defined here. Holder is the name of the class. H is the reference I pass. Now, this H is local for which block? Bump block. It also occupies the memory from stack. This H is local for main. This H is local for word holder. Local variable name can be same. But if it also hold the same value 1000, at the calling time I pass this H, at the definition time I pass this H. So this H and this H hold the same address or different address? Same. When both point to the same object, what actually happens? H dot held plus plus. Held value is 100. 100 plus plus is word 101. After the execution is over, it will back to this line. H dot held. What the value is? 101. Check the result. 101 is the result. I just show you what actually happens here. 101 is the result. See, that is D is the result. Here you check. Now, I move to that is word sixth program. See, carefully check the concept. It is a very easier concept. You see how it will work. Today, I cover, this is the sixth application. That is the last program I just explained. Every day, I give you elaboration of some, that is what programs, then you understand how it will work. Now check here, what I can do here. It is the concept of exception. You know that execution starts from which block? Main. I'm just using the try block, fine. I call a method. Have you defined a method? Yes, I'm defining the a method, hit enter. Main is static, a method is static, they call it directly, hit enter, inside the try block. But it generates what? Exception object. Listen. It is what? Checked exception. Exception is checked exception, that is checked by the compiler. Now I generate the exception, but I am not handle it. You know that finally never be called as exception handler. Catch is exception handler. I generate exception, but I am not handle it. So program must terminate at compile time. But here what I did, I throws exception. When I use throws exception, I instruct the compiler, do not terminate the code. Throws means caller is bound to handle it. Who is the caller of a method? Main. If main is unable to handle exception, then program is terminated. But listen here. You know that try block executed means one block must be executed. What is that? Finally. Now, when the finally block is executed, what did it print first? It print finally. After that, compiler check the caller handle or not. Yes, the caller handle it. I throws the exception. Caller handle it. Next, catch block is executed. What did it print here? That is the exception. You know that now the exception is handled. After that, what did it print here? That is the finished. So remember, this is the way of execution. Try block executed means one block must be executed, but it is checked exception. It terminates the code at the compile time. If I'm not handle it, here I'm not handle it, but I use which keyword? Throws. By using throws keyword, I instruct the compiler that caller of the method. Who is the caller of the method? Main. Main bound to handle. If a main unable to handle it, program terminated the compile time. But here the catch block is not executed. Here the finally block is first executed because try block executed means first the finally block is executed. Then caller handle the exception, catch block executed. Here you see this is the result. You check here, that is what is the result here? That is the finally exception and finish. The C is the result. So thank you. Today I show you 6 programs. I explained 6 programs. If you have any queries, then you just communicate with us in our, that is what, specified address. Then we are must helping you to solve this type of problem. If you are develop this type of code, small application that give you some courage to write the code. For a developer, it is not mandatory that you must be strong, you must know some other languages. For Java, you have the knowledge of only object-oriented concept. Thank you. That's the end of today's session.